quite often you use random numbers in R. For example, when you ask for randomly distributed numbers, normally distributed random numbers, or when you sample from a vector or something like that. But there is really no such thing as real random numbers in computers, and one might argue that there is no real random numbers anywhere in the world actually, but at least not in computers. So what happens when you ask for a random number in R is that R takes a seeding value, a numeric value, could be any value, and then applies some sort of complex formula that uses this value and calculates a long series of numbers. They are non-random because they are purely based on this seeding value, but the formula is complex and works in a way that these numbers look completely random. Then R simply gives you the first number in this row, one could say, and if you want another one, it takes the second and then third and so forth. To make sure that not everyone gets the same seed, it uses the time according to the internal clock of the computer, and then uses this value to create the random numbers. Therefore, anyone else asking for random numbers won't get exactly the same values because it's probably not exactly the same time when they ask for them. It is, however, possible to force R into using not the clock, but to use a specific number which is provided by you. And the point in doing so is that you can get reproducible random numbers. And the reason we're talking about this now is that we use that in some of the exercises because we want to know that you all get the same random numbers in order for us to check that you have gotten a correct result. But it can also be used in research. For example, if you're using a resampling strategy in the statistical analysis, then you would actually get somewhat different result each time you perform the analysis, although the data you're analyzing is the same each time. And that could be a problem. It could be a problem because you might be tempted to resample over and over again until you get the result you want, which would obviously be cheating. But it could also be useful if you, for example, need to extract some value that you forgot to put in your manuscript, and then if you perform the analysis over, you get another value, and all the values are different, so you would have to update a lot of values in your article. In this situation, you can instead lock the seed value, and after that you will be sure to get the same results each time you perform your resampling. Of course, you shouldn't try different seed values until you get the results you want, but you have to decide beforehand what seed value you should use. And the command you use to set the seed is set.seed. So I thought I'd show you how it works. Here, for example, I ask for 3 randomly distributed numbers, and I get them here. If I do this once again, I get 3 new numbers, obviously. And if I do it over again, I get 3 new numbers. So I get a lot of different numbers. Let's clear the screen here. If I now set the seed to 42, could be any number, of course, but 42 is a nice and round number, and it's the answer to the question of life, the universe, and everything. So if I use this and then I ask for 3 random numbers, I get these 3. They look random enough. But if I now set the seed to 42 once again, then I have reset everything to the same situation as before here. And if I ask for 3 new random numbers, as you can see, I get the same random numbers once again. Very convenient.